Hello everyone, Eric here, and welcome to my computational science video tutorial. In this video, we're going to continue looking at condition statements in C++, and we're going to write Hello everyone, Eric Severy here, and welcome to my computational science video tutorial. Today we're going to continue looking at condition statements in C++, and we're going to do that by looking at a couple examples. So I'm going to write some example functions, and the first one is going to be a function called sine, and what that is going to do is it's going to take, I'm going to just use an integer, and it's going to tell us the sign of the integer. It's going to tell us if the integer is positive, negative, or not. And I'm just for now going to type return 0. So I'm just going to create the skeleton for the function. We're also going to create another function called parity. That's going to take an integer and it's going to tell us the parity of the integer. All right, and what the parity is that tells us if it's odd or even. All right, and for this, it's going to return 0 also. So I'm going to add a couple comments here. I think it's always good to have some comments. You know, 1 for positive. So sine returns 1 for positive. I'm going to say -1 for negative, and 0 for 0. So with the sine function, it's very common. Now this is not like sine and cosine. It's just, it sounds like that, but it's just the sign of a function, and it just tells us if it's positive, negative, or 0. All right, and we're going to do this with the if statement. So we're going to say, hey, if x is greater than 0, then we're going to return 1. What am I typing? Else if x is less than 0, then we're going to return -1. And then I can say else we're going to return 0. And in fact, for this, we don't really need the parentheses around these. I do kind of like them though. Oops, what am I doing? My key got moved on me. So we don't need these parentheses if we just have a single line. So these kind of curly brace parenthesis type things group together multiple lines. I like to use them because if we go back and add lines later, they're there. You know, if we try to do some sort of control or error checking and stuff, I always like to just sort of have them. I'm very cautious about those things. So here we can see if x is greater than 0, we're going to return 1. If x is less than 0, we're going to return -1. Otherwise, we're going to return 0. And of course, if the integer isn't bigger than or less than 0, it has to be 0. All right, for parity, actually, before I do parity, let's check some stuff in here. I'm going to say int x equals 0, y equals 12, z equals -24. Actually, I'm going to put w in here. W equals, how about -5? Okay, so now we have 4 different numbers. And what we're going to do is we're just going to check all these things. And we're going to say w sine w. Actually, yeah, I'm going to put some stuff in here, though. Between the w and the sine w, I'm going to put that in. There we go. Sine w, and then we're going to put another comma in, and then we're going to have parity w. And then we'll just put the end of the line. And then we can just copy and paste this 4 times. We'll do wx, y, z. So we can come across here where we see the w. We'll just change that to x. And x over here for the parity. Then we'll put y in for the parity, y in for the sign, z, and finally z. So just a little bit of copying and pasting. Later we'll learn how to do loops, and when we loop over this, we can simplify this even a little bit further when we have loops and arrays. All right, so let's just run this real quick. I think I've run this program before, so we don't have to do anything fancy. All right, and right now the parity should just be returning 0, so the parity is not going to give us any kind of accurate answer. However, here we go. So we see, let's make this a little bigger. All right, we can see we have minus 5, and the sign is indeed negative. 0 has a sign of 0, 12 has a sign of 1, and negative 24 has a sign of negative 1. All right, so the sign function is working. All right, now we're going to work on the parity function. And what I'm going to say is I'm going to say parity returns 1 for odd, 0 for even. Or we could say 1 for odd, 2 for even. Because basically with parity, we want to know if a number is odd or even. I kind of like 2 for even, because otherwise we would just use the modulus operator. So what I'm going to say is I'm going to say if x mod 2 is equal to 0. Now what the mod means is it means the remainder after division. And if we divide a number by 2, if there is no remainder, or no decimal point, so if we divide a number by 2, I turned off notification. All right, so what the remainder operator does, just a quick reminder, it tells us, so what the modulus operator does, it tells us the remainder after division. So sometimes I call it the remainder operator, sometimes I call it the modulus operator. It kind of does both. And here we're using it because if we divide a number by 2, if it divides evenly, if we have 0 remainder, that means everything went in, there's no decimal, and the number must be even. So in this case, I'm going to return 2. Else, and I can basically say else if x mod 2 is equal to 1, then I'm going to return 1. Now, sometimes with this kind of code, C++ might get nervous because it might be possible that you don't get to a return statement. So in this sort of situation, I think it would be a lot safer to just have the else instead of an else if. And if we have the else, we don't need this statement at all, because we know that it's either going to be 2 or it's going to be 1. And there's no other value we can have. So if x mod 2 is 0, then we're going to return 2. Otherwise, we're going to return 1. And because we have just a plain else, our C++ compiler won't have to worry. So let's run this and see if we get the right parity for our numbers. Just taking a moment for this to build. All right, and here we go. And we can see everything appears to be fine. So negative 5 is an odd number, so we get 1. 0 is even, so we get 2. 12 is even, so we get 2. Negative 24 is even, so we get 2. All right, so we are getting the expected results here. All right, and I just want to add one more kind of quick comment about if statements. We often find that we can nest if statements. We can say if w equals 5, we're going to do something, but in here we could also say if x equals 0, if y not equal to 12. Oops, I meant to put a y here. So if y is not equal to 12, then we're going to do something, else we might do something else. See out this is printed. So we can kind of have these sort of deeply nested if statements. And I do like to point out to people, it's always a good idea to try to reduce the amount of nesting. One way we can do this is through and. Like here, what we're really saying, if we could say if w equals 5 and x equals 0, because these two are being linked to bring us here. So we could say if w equals 5 and x equals 0, then we want to do this quick check. But yeah, I always think it's a good idea to try to reduce the amount of indenting we have or the amount of nesting we have. And in coding practices, it's always good to have your if statements indented. Technically, it's not necessary in C++. It is necessary in Python. C++ joins the code using the curly braces. So you can put everything on one line, but it's incredibly difficult to read. So I advise against it. So I did want to just kind of point this out as we're finishing up looking at control with if statements. And, you know, logically we can do a lot with this. You know, you might have to sit down with pen and paper to work it out. All right, that's everything for this video. Thank you for your time and keep on coding.